So let's take a look at this problem. It says given f of x equals 2x minus 1 and g of x equals x squared minus 4. What we're dealing with here is the first one's going to be a line, it's 2x minus 1, and the second one is going to be a parabola. And it's going to open upward and it's going to be shifted down 4. That's the only difference here. Now part A says graph f and g on the same Cartesian plane. So that's what we're going to do first. So f of x is in slope-intercept form, so I'm going to plot the -1 first, and that's going to be here. And then from there, I'm going to use the slope, and that's really just 2 over 1. So I'm going to go up 2 and to the right 1. So that's going to put me here. And I'm just going to continue to do that, just so I can get a nice straight line when I graph it. Sometimes that's really handy. I'm going to do the same thing in the other direction. So that means I'm going to go down 2 and to the left 1. And then just kind of fill it in there. Oops. I want that to be a little tighter. All right, so there it is. So now I'm just going to draw my line. So there we go. Now what we're going to do is we're going to graph that parabola. So I know right away that the vertex is shifted down 4. So there's 1, 2, 3, 4. So 4 is going to be here. And from there, since I don't have a multiplier on my x, I know I'm just going to go to the right 1 and up 1. So it's going to be there. Let me fix that. There it is. That's better. And then because of symmetry, I'm going to be on the other side as well. Then when I go over 2, I go up 4. So I'm going to go up 3 more. So 1, 2, 3, it puts me here. So because of symmetry, I'm also going to be on the other side. And then we're going to go out to 3 for the next one here. So when I go out to 3, that means from there I'm going to go up 5 more. So 1, 2, 3, 4, 5. So it's going to put me here. So again, the symmetry. That's going to be over 3. So 1, 2, 3. So it's going to be there. All right, so now we can actually graph this one as well. So there's the first, and there's the second. So we actually follow that information here. So I should say y equals g of x. Actually, I'll write it on the other side. And f of x equals y. I should just say y equals fx. Okay, so there's our two functions, and we did part A. Now let's take a look at part B. Part B says solve the equation. So what that means is I have f of x equals g of x. So I can just simply plug it in for that. So f of x is 2x minus 1. So I can say, hey, 2x minus 1. And then I can say equals. And then g of x is x squared minus 4. So I just put x squared minus 4. And then I just solve for x here. And to do that, since I have a squared here, I have to get everything on the same side. So I'm going to move everything to the right. So it's going to end up being 2x squared minus 2x. And then when I move that 1 over, I'm going to have to add 1. So it's going to be -3, and that will equal 0. So now I just have to solve this equation. And this one actually factors nice. Put an x here, put an x there, and this has to be a -3. So I'm going to have -3 and then +1. The signs have to be different because that's a negative there. Then when I add that, that's going to be -3x, +1x. That's going to give me a -2x. That's how I knew the negative went with the bigger one. And that equals 0. So what we end up with for answers here is either x plus 1 equals 0 or x minus 3 equals 0. And if we solve for x here, x is going to equal -1 or x is going to equal 3. Oops. So that tells us where we actually meet, where our lines are equal, at least for the y values, where our y values of the line and the curve are equal. Okay, it says part C now. We found out what that was. We solved it. Part C says use the result from part B to label the points of intersection of the graph of f and g. So now I know right away that the x value for this point here is -1 because of this value here. So I know that's -1, and to find the x value of that, I can plug it into either equation, because think about the y value there. Since that point is on both of those graphs, the y values and x values are going to be the same. So I can pick any function to plug it into. So I'm going to plug it into the 2x minus 1 one. So 2 times -1, minus 1. So this is going to result in, for my y, it's going to equal -3. So this is actually going to be -1, -3. And because I did such an awesome graph, you should be able to see that. Okay, so for the next one then, the other point is actually at, the x value is at 3. So I know for this one here, the x value is going to be 3, and just because of the graph I can tell what it is, but we're going to do it algebraically just to show that as well. So that's going to be y equals, now I'm just going to plug the 3 in there. Now I picked the line because I don't know if it's easier, just squaring and adding minusing a 4 to it, so I don't know which one's easier. But it'll give me the same result. So this is going to be a 6 minus 1, which is 5. So there's our other point there. So we found the labels for the points of intersection of the graph of f and g. Now the next one, it says shade the region for which f of x is greater than g of x. So for this last part, to see where f of x is greater than g of x, it says shade that region. So when I look at my graph, my f of x is the line and my g of x is the parabola. So essentially all I have to look for when I look for f of x being larger, they mean those y values. So what I'm looking for is where are the y values of my f larger than my g of x. That would mean where my f of x is above my g of x function. And that happens in here. So that's where that happens at. It says shade that region. And that's the only region because once I go past that, my g here is above my f, so therefore it's less than. It flips around the other way. And the same thing on the other side. If I go to the left of -1 here, I'll see that my g, no matter what value I pick, the y value for my g is a lot larger than my y value for my f. So that's my region. That would be number D. So that's it.